Good evening everyone, this is KIRANKUMAR BK. Now I am going to make a video regarding the design of a matte foundation using safe software. This video is done as an assignment which was assigned to me by Skyfi Labs. So thanking Skyfi Labs, let's start with the video. First go to File menu, go to New Model. So here there will be design data will be obtained. Now change the design code to IS 456-2000. Then come to design preference. Here all types of captions will be there, like minimum cover slabs, minimum cover beams, pre-stress check. Let's go with the minimum cover slab. Then change the clear cover top to 50 mm. Then this to 50 mm. Preferred verso, let's take it as 22 mm. Okay. The unit should be in metric. See, let's check. Just click on that. Click on metrics. Okay. Different types of model is there: blank, flat slab perimeter, two-way slab, base mat, waffle slab, brick slab, single footing, common footing. So for this video I'm selecting this grid only. So let's do this rotation 19 line. Grid spacing be 1 meter by 1 meter in x and y direction. We have opened the ETAPS previous model from which we are taking the distance and put it in this safe software. We are with help of this ETAPS software, the readings are taken and it is being entered in the safe system software. Just click OK. Cartesian, let this be coordination system be Cartesian. Just give a click on this. See, after doing this, go to define properties, materials. Similar, like this software is similar to ETAPS. We will define the materials like steel, HYST. Change it to rebar. Steel characteristic strength or will be 500 Newton per millimeter square. Change it to 500. Minimum yield stress, minimum yield tensile stress 15% of that is 560. Then again add a new material, concrete M30. All these things I am entering with from the what are the descriptions or what are the result where is analyzed from the ETAPS, we are noting from there. Okay. After doing this, go to define slab properties, add new properties, change it to matte. Here we are designing the foundation through matte foundation. Change it to M30. Here change the from slab to matte. We'll consider thickness about 850 mm. It should be in thick plate. Orthotropic means lots of things will come. Effective thickness, twist local 1 2 direction. I'll deselect this and I'll go with thick plate. Select OK. Then OK. Again define. Go to column properties. Add new properties. Two types of column is there for different dimensions, namely 500 mm column and 600 mm. Change the material to M30. Change here the dimensions. Add new property. Click on add new property. Change it to M30 grade 600 by 600. Okay, we had named or assigned the two column properties. Close that. Then we will go to draw slab areas. For drawing what you call footing, see mat, the mat we are drawing, that section will be after on this mat we are going to name or draw the column. Okay, slab is there, mat is there, go on drawing, select this point from here to the end point, a rectangle or a square shape, come to the first starting point, you click on that. Okay, now select this what rectangular area, click on this, so first entering, after escaping click on this, see you can see one areas and 4 edges are selected. Go to define, go to edit, not define, edit areas. We need to prolong the area by 2 meter and 2 meter on the either sides. So expand shrink areas, change the value, enter the value which needs to, you need an offset or you need to expand, say about 2 meter, which is 2000 millimeter. See, you can see the area is got extended by 2 meter on all sides. Now you can draw columns. Okay, here this is column, here you have to select column, the distance let's keep it as 2. At every 6 meter columns has been placed. You can see here same things we are now going to draw here. Okay, change it to 0 and here also have to 2 meter. Now you can draw. See, while moving the cursor you can see the distance. With the help of that you can place the column wherever it is needed. At every 6 meters let's give an escape on that. Now change the column dimensions to 500 mm, draw column here at an so drawing the column part is done. You can see here, just have a cross check in E-types. Okay, after doing this thing we are supposed to draw what? Draw design strips. So you select on that, column strips, change the width to 4 meter. Okay, from here, A in the sense horizontal. Now change it to B and repeat the procedure vertically. redraw the strip, change it since it was bit away from the grid lines. Now it's okay. After drawing these grid lines, just see their properties. Change it to HYST 500. Okay, you can figure it out, the difference. Change it to okay. All vertical parts are finished. Let's finish it with horizontal strips. So this part is finished. Now after this, assign the properties like soil and load. For that, select on this footing surface, to select properties, go to soil subjects, soil, okay. First just define the soil properties, modify show, subgrid modulus, change it to 3. Okay, now it's been selected. To assign support data, then soil, okay. So the soil properties has been assigned. Now we are supposed to assign the loads on each column. This you have to do with the help of E-tabs, where you analyze the E-tabs. So after this, go to table. In the table, go to element output, see the element force in column. All sorts of things will be there. Story 1, story 2. You can change the loads, dead load, live load. You have to apply both. In here also, column 1, case type. From the see, you can make out different sorts of loads here. It's sorted from ascending order, from station. Also sort ascending in below. By seeing here, you have to apply the loads here. So I'm now going to do that. You need to apply load on each. I had made a note in this notebook. With the help of that, I'm now going to assign the loads. So let's get started with it. Here you can see only these two columns are of different dimension. Column say about 500 by 500, all are remaining 600 by 600. So let's start with this column. Go to assign, go to load data, go to point loads. See, you can assign here. Go to data. First let's here in gravity column you are supposed to enter your data or load which you have got. So I will go. change the dimension to 600 by 600. Set. Okay. Again select a point. You can see that points has been selected. Now assign, go to load data, change point loads to, change it to live load, change this to how much? This is how you are going to apply load for each columns. Just repeat the procedure for all the columns. This will take some time. Again select a point, load data, point load, change it to that. Okay. Okay, select properly, otherwise the design steps will get selected. To load data, point loads, dead load, these all loads information will be obtained from eTabs. So from there you are assigning the things. After entering the data, just you need to cross check it with the values which we will going to design now. That will be taken further. It is a bit tedious process which will take some time. successfully access while doing the assigning the data. Now the loads are fully assigned for all columns of dimension 600 by 600. Now we are going to assign the loads for column 500 by 500. The procedure is same. Go to load data, forms load, change it to okay, let it be dead itself. Now change the dimension to 500 by 500. Repeat the procedure. All these loads are assigned by analyzing of the loads from the structure from E tabs. Again assign the load, change it to live load. So now the entire columns have been assigned from the both dead loads and live loads. To check the loads which you are assigned to the column, just give a right click on this column. Here you will see the caption called design, loads, geometry and assignment. Click on loads. click on that point, go for loads. Yeah, now you can see dead load and live load. This is the dimension, this is what you have applied. Click on to the point. Now we'll check for 500. See, dead load of dimension 500 by 500. This can be checked for all entire columns. I won't check for all entire columns, so I'll just go for analyzing it. Go to run analysis. Save the file. Okay, the file has got saved. It will take some time to get analyzed. Wait till the analyzation is completed. Okay. Okay, now go for detailing part. Sorry, display. Go for run analysis and design. After run, you have to run analysis. You have to do run analysis and design. Then you need to go for display option. Then there is an option called show punching shear. Just give a click on that. Okay, so this indicates the punching shear value of every column. So the criteria of your design is that the punching shear of each column should be less than 1. So in order to make the punching shear value less than 1, you have to increase the thickness of your mat, that is the depth of the foundation. So how can you do this? Do that means you have to first unlock the model. Okay, then go for define slab properties, modify the property, change the thickness to 1300 mm, give a OK, then again run analysis and design. Okay, now again go for display and check punching shear. Okay, but some values, some punching shear values of columns are still more than 1. So again just repeat the procedure. Unlock the model, say OK, go to define slab properties, modify slab properties, change the thickness by 200 mm. Just again run the analysis. Okay, then again go for display option. Okay, analysis is completed. Check the values. Okay, now all the punching shear values are within the 1. Okay, in this detailing part, okay, display part, you can see many options like show undeformed shape, show load, show deformed shape. You can give click on anything. Now I will give click on show strip forces. I'll go with dead load. Just give a apply. See, you can see the forces. I'll change the layer from A to B. Just give. See, here in display option there is a option called show values of diagrams. I'll give a click on that. You can even see the values now. This is again, I'll go for display, show slab design. I'll give it minimum, impose minimum reinforcement, apply. See, I'll change the layer, apply. Again, now I need to check the crack width. Click on apply. Okay, close. See, it is all in the range of e to the power minus 3. You can see the here crack width. As you move your cursor, the crack width changes. See. Since it is in the range of 10 to the power minus 3, these all are negligible. What else is left? show reactions, anything you can say. See, this is dead load, I need live load, so I will just change it to, see, it got changed. Types of reactions, soil pressure, I'll just give an apply. See, show deform shape from application of dead load. This is how it looks. Okay, now I'll again run analysis and detailing. Click on everything, click on this. Okay, now this is the detailing part. Go to model, if you go to model, see, display detailing, go for detailing, drawing component views, drawing list, general nodes to rebar shapes. These will be the shapes of rebar. This 00 indicates the code, 11 indicates the code, this will be the shape of that. This will be the containment rules. Individual slab views will be selected. Rebar plan, this is the plan, click on that, zoom in the cursor, see, top rebar plan, bottom rebar plan, captions. Okay, this will be the reinforcement profile. You can even have the section part of the column. See, so this is the mat, you know, the thickness, how it looks. That was section 1 and it will be the section 2. Dimension, bar diameter, top bar, bottom bar. This is cut element at a spacing of 1 meter. The depth of mat, that is, we have kept it as 1500 mm. So this is how we will analyze the building or mat foundation by using safe software. So lastly, on this I would like to thank again the Skyfi Labs. This is my third assignment and they had encouraged me from their videos. They have really taught me well, and I think had encouraged my language, my knowledge in the software skills. So I would love to finally thank Skyfi Labs. With this, I am concluding this video.